Alright, Chapter 15, Mastering SolidWorks. Chapter 15, Patterning and Mirroring Components. SolidWorks assembly work component can refer to either parts or sub-assembly component parts. Can be patterns of parts, sub-assembly components of parts, and sub-assemblies. In this chapter you will learn to create local component parts, place initial components, feature-driven component parts, examine the other component pattern options. I said patterning and mirroring. SolidWorks assembly word component can refer to parts and assemblies. Component patterns are patterns of parts. Sub-assembly components of parts and a sub-assembly. In this chapter you will learn to create local component patterns, place initial components and feature-driven component patterns, examine other part and pattern options. Component patterns. Component patterns come in several variable varieties, as shown in Figure 15. One, only those of the linear and pattern, circular patterns do not require reference outside assembly, which is to say most component patterns are going to require some sort of external in-context reference. These references can be sketches, pattern features from parts. So we've looked at the type of the component SolidWorks as well as the linear pattern, circular pattern, sketch, curve, chain. Mirrors components is an assembly far more complex. Mirroring features in this part. SolidWorks provides options: mirror parts, mirror positions, left hand, right hand version, parts, mirroring parts, sub-assembly, top level assemblies. Using local component parts. Local component patterns, Local component patterns are limited to linear and circular patterns. SolidWorks assembly do not offer all options available to pattern features. In parts such as table-driven and fill linear patterns, description and directions work like linear pattern features in parts must be reference line, axis, edge, plane, linear face, so on to establish direction. Remember, it's best as possible to reference items close to home local assembly file rather than selecting some external part of the geometry in assembly with the means of pattern features. Use either local reference geometry for an assembly, such as axis, planes, assembly sketches, and or model geometry from each part, such as solid surface edges sketch and reference geometry. Keep in mind this is the concern about the external circle references. By using references belonging to assembly rather than parts, you can avoid some common reference pitfalls. Alright, best practice. If you have the feature pattern in part, you should take advantage of the end feature for the driven part instead of the local pattern. The rebuild time of the may be no longer, but associated between the parts of assembly helps maintain the design intent. Creating local pattern references. It's best to use references if they're not dependent on the part geometry. Remember, when the part geometry is used to assemble the pattern reference, the parts must be solved first, sketches, then features rebuilt. The mates must be solved with the positions of the parts. Any in the context references must be solved, which can change the part geometry. Then any of the sum of the feature for the component patterns must be solved. The result of the best practice use the assembly reference geometry and their assembly sketches without references or pattern direction references. The assembly sketches should sit at the top of the assembly feature manager. Ensure that they do not pick up the reference history-based features, the design tree, mated components, patterns, assembly features, and so on. Local pattern really requires a reference from pattern. Will have no alternative. However, they can avoid this situation using sketch assembly skeleton to which parts are mated. Use the pattern references. Then you should do so. At all costs, you should avoid using in-context features to assemble the reference geometry depending on the part of the geometry, assembly features, and other sketches of the local pattern references. Using instances to skip option. Instances to skip option with the component pattern shown in Figure 15.2, which works like an equivalent option with a feature. Clicks the dots with the graphic window of the toggle each instant without the pattern on screen. Instant of the keep the use of the pink dots. Instance of the skip the use of the orange dot. The colors are almost indistinguishable at relatively wide spacing. Figure 15 shows instance of skipping option direction, and we've skipped it because of the colors. Performance of the best pattern performance. You should assemblies or pattern unit much as is practical. Multiple patterns or individual components are not insufficient. Single pattern, multiple components. Single pattern, single component itself with sub-assembly the best choice available. Another performance issue in the fact that the component parts require the external reference for the direction of the center of the pattern. The external reference have the potential to increase the rebuild times. It do not choose them carefully. Reference geometry internal to the assembly would be the best choice. Although many would experience performance problems with patterns, they can also significantly decrease the number of mates in assembly, which may also improve performance. Patterning the seed only. All aspects of the interface should be familiar to you with the direction, instance of the spacing pattern. Seed only option is you with the feature patterns. The This option is designed to allow you to create a single pattern in two directions that are separated with 180 degrees. The instances do not overlap one another. For example, if you take a two basic direct pattern, change the angle between the directions so that the anti-parallel would be going to the opposite direction in all component instances, they were better between the two legs of L created with the two directions will overlap one another. One flaw of the feature will not allow you to select the same linear entity. For example, X is both directions so that an example. Figure 15.3, you have to find the separate entities. In this case, an X with the edge of the end. They are parallel assembly used for this image available to download material. Chapter 15 as pattern sheet only. Solidworks assembly template that acts if the middle mouse button or management MBD folder is named X-axis assembly dot. Alright, it says you use a pattern seed only option 2 directional. You can either go X on the X-axis, you can either go up or down. Using mirror components to leave the feature of the assembly tree just as pattern feature do, but it gives you the option to align them each mirrored and decide the pair of parts, whereas opposite hand version, which can use the original and mirrored location. Figure 15.4 shows property manager assembly feature note for the mechanism linkage requires only identical part mirrored position from the breaker level. Assembly however requires opposite of the hand end for the mirrored position. Examine the assembly more closely. Open mirrored component solid assembly. 15.4 mirroring components assembly mirror component tools. It shows mirroring that. Workflow of mirror component assembly with these 3 steps, second of which shown in figure 15.4. Selection, select the parts of the subassembly that you want to mirror along with the plane which you want to mirror the components. Select the orientation, and if the components must be in the opposite hand version for the others, you can toggle the available option for placement. Opposite hand version for the parts, the opposite of the hand version. You can assign them to new parts and derived configurations. First step should be self-explanatory. Just select the parts and plane that you would in other situation. You move the steps and clicking the arrows in the blue circle upright corner mirror components property manager. It shows a setting orientation. Second step requires some explanation. In the property manager, labeled step 2, set the orientation in figure 15.4. Notice that there are some of the mirror symbols in front of the brake lever assembly, brake mount, Bible, bike selection, and orientation components and panel. The mean with the documents must have the mirrored instant with the control of the option. Selecting the part of the assembly orientation components, list box, and clicking, creating the opposite handled version button at the bottom of the property manager. Another thing you need to do in the second step is correctly orientate the parts that do not require the opposite hand version. Do this, select the part orientation components, a list of the box, such as the grip, Bible, bike part. Click through the double arrows just below the selection box. Figure 15.4 message 2 of 4 is grayed out because of the parts require the opposite hand selection. With a click of the arrows, part repositions another possible mirror position orientation. The mirror type option, bounding box center of mass determines how mirrored component is positioned. You create opposite hand version. They position automatically determine the option. Do not make the difference when you mirror the component. The first, if you consider the mirror of the plane, then you have to consider the pivot that orientate for the component that is positioned. Determine the reorientate component control. In the case given with the 4 different options of the pivot orientation, note that some of the options change if you're using a bounding box for the center of the mass. Essentially, 2 mirrors are occurring. The first mirror about the selected mirror plane, and the second mirror is either of the bounding box center of mass. Is not cricketable along the components of the correct motion and position orientation. Using reorientate components option to determine that. Figure 15.5 shows all the combination reorientation components 1 through 4 of the both bounding box center left and center of mass right on the mirror types. The correct result should be obvious that there could be more than one correct result. Or creating opposite hand versions. And third step of the opposite hand version be paneled with the property manager only with the document that must be changed with the listed. In this case, the brake lever assembly is made with the 2 parts. Lever part can be with both the left and right hand versions, but in the mount must have 2 different versions of the part. The means available must also have 2 versions of the mirror components. Functionality is fantastic, involving well thought out process. To make the mirrored version, you have the option to create the new file to create a derived configuration, and with the existing file. Are you setting up these options? Solidworks display with the previous review, the result of the graphic window previously put with a transparent, make them maybe a pale yellow. You want to change them with a dark orange to the tools option, color, temporary graphics shaded. You can see how the parts are oriented to immediately fix any of the problems that arise. So we have the bounding box center and center of mass. With large assembly, large set of mirrored components, visualization may be more difficult. The process demonstrates on here on how the works give the complete set of options. Work through the process mirroring parts assembly with the top level assembly. Tip: isolate selected component option. Turns off the display all out of the components being with the mirror while working on the option for the selected component that can be useful with the mirroring many things at once. Completing the task. When you finish with the task, you click the green check mark. In this case, Solidworks displays a message that one made with the mirrored assembly cannot be duplicated. Shown in Figure 15.6. After testing the motion of fork linkage and the missing mate does not appear to affect the assembly. 15.6 shows the mate is not created. The mirror task is completed. Mirror component feature leave the marker assembly feature manager after the mate's holder. Figure 15.7 notice of the brake lever assembly, brake mount, and Bible bike documents mirror default configurations as was established while mirroring the assembly and the parts. 15.7 does examine the list of mirrored parts. So mirror 06 and mirror 07. If happening in the mirror to be mirroring flexible subassembly, you want to mirror to subassembly at least give the move simultaneously. You can either synchronize movement of the flexibility subassembly component option. This option links the mates of the subassemblies. Using feature-driven component parts by very nature, feature-driven component parts are to defy some of the best practice suggestions in this book. Because the pattern is driven by part, geometry of the part must first be solved with solving the feature of the internal part. They must be placed by solving the mates. Only then can the feature be driven in part to be solved. Nevertheless, should you feature-driven with the part instead of local patterns when available because of the parametric link, parametric associative as after and all one of the main benefits the SolidWorks offers. Note, for the feature-driven the component part patterns for the location of the initial component is important that you need a placement of the initial component with the position of the original feature for which the pattern was created. Note one of the patterns is an instance, so you can get around with the requirement of if you selected the seed's position option. When you do this pattern instant, it appears all with dots. You can select with the instances that you use the seed. Again, selected dots are blue and unselected dots are purple. They're nearly indistinguishable size and spacing of the dots. Figure 15.8 show the property manager interface the feature-driven the component pattern sample the file of the download material a chapter under the file name feature-driven pattern solid assembly. Feature-driven component pattern-driven instance components pattern-driven feature component instance skip by driving feature option propagate component level. Visual properties. You can nest feature-driven component properties such as the component pattern is patterned by another component pattern, just another user you as doing. The feature pattern, second pattern can be a local pattern or a feature-driven pattern. In this case, shown in Figure 15.8 is you the instant skip option, selecting multiple adjacent instances, a box or a lasso with a box or a lasso. Alright, creating a chain pattern. When having been using a bicycle example file for much of the book, so using chain pattern feature for the appropriate here. Start with a sketch for the chain line. SolidWorks refers to it as a path the chain of the real bicycle would flex. But for the SolidWorks purpose, your chain must be planar. The sketch must be also clean, with no gaps overlap. It may be a single continuous loop, whether all the need the tangent to end, although in case you may notice that the chain interferes with the drive side, chain stays with the highest gear, but in the left, you work out with a design exercise. Figure 15.9 shows the sketch of the chain path. Next, you need to create links in your chain. Bicycle chains are made in inner and outer links. Other types of chain may have just one element. You may choose the model chain links. Another way to choose the way of links chain is manufacturer assembled, but Figure 15.10 shows you how to choose a model chain that works best with SolidWorks chain pattern feature. Chain links made separate, are made of separate parts. Next, the link needs to be placed in the assembly. You may choose the separate assembly for the chain, and the chain show the assembly created with the feature with the several part instances under just like a pattern of the links may be placed in the chain pattern path sketch. Chain pattern feature you don't need to mate them mate them there yourself. The chain pattern interface walks you through this process shown in 15.11. 15.11 shows chain pattern pitch method, shows different chains, chain path, fill path, number of assembly, phase 1, phase 2, path alignment, plane, chain 2, phase 1, phase 3, phase 4, plane alignment, plane, dynamic, static. Alright, if you choose third option, pitch method, the connection link, you need to have two separate link parts, at least for the single link with its alternating position. The connected link pitch method activates second chain group U of the path alignment plane to make sure the correct place faces of the links are mated. To get a chain pattern perfectly end to end, you have to work with a path sketch length adjusted until the first and last link connects. The chain pattern can help you get an idea on how long your actual chain needs to be, as well as the producer looks like a visual for your drawing situation where you need chains to be non-planar, such as the actual application bicycle chain. This is something you can simulate with this tool. The chain pattern helps you to identify the design where the chain stay on the bike needs to be altered, avoiding rubbing of the chain in the highest gears. Dynamic state option allows you to disallow motion. Respectively, the advantage of the disallowing motion would be that you would avoid calculating all the associated mates. Once the pattern is created, the necessary links components are kept under chain pattern feature, partially shown in figure 1512. Alright, so your whole chain pattern had a whole bunch of links to it. Understanding other pattern options. Solidworks provide additional options to help you work with patterns. These options help you with the component organization visualization, which are always kept the key elements on when you're working with an assembly. Figure 1513 show the right menu mouse button, menu component part pattern selection relevant with the patterns available. The right menu mouse button for patterns. Dissolve pattern option. Remove the component instance from the pattern feature of the parts of them into the main part. Assembly feature manage of the components just become the normal components in the assembly without intelligence of the pattern feature and placing them. Components are left in the assembly without any mates and or any sample, simply floating in any position. Add to new folder. You can add patterns to the folder. If you have the list of patterns at the end of an assembly, you can make the sense of the group the related folders. Purpose of the organization same with using folders, features, mates, and components. Component pattern display options. You can change the appearance of the individual component pattern instead of the individually collectively with the pattern feature usually display. Shown in 4 columns right of the feature manager, figure 1511. Remember, you can access display pane quickly and present by pressing F8 key. Our component pattern configuration, individual instance of the component pattern also enable you with the control configuration created with the pattern. You can select the individual instance of the chain with the configuration. Can be extremely useful if you have the mechanism subassembly shown in various positions. For example, the pattern around an indexing dial. The component of the right menu button, right menu boss, right mouse button menu, and then. Tutorial creating component patterns. To learn how to create component patterns, follow these steps. Open a new assembly, create with a new 3D sketch for the draw 3 line with the origin out with the odd angle so that they do not pick the horizontal vertical automatic relations. Draw the 2 lines with the rotate them view with the press of the tab key with the draw of the 3rd line. Apply the sketch relationship that each line lies on a parallel plane. 1 line on front of the one on the front, 1 on the top, 1 on the right. Make sure that none of these lines overlap. Click close with the exit the sketch when you're finished. Open the pattern part, solid part. The download material of this part is already contained several features that can use to practice working with the feature-driven component patterns. Insert part with the new assembly. Create step 1. Locate the part assembly. Alright, insert the part newly assembled, created in step 1. Locate the part and assembly origin, such as the part origin matches the assembly origin. Place part called pattern part, solid part, and assembly. Place small part with the original feature, rectangular pattern, round holes near the origin, shown in figure 1514. All the original feature colored red. Remember that all dragging circular edge flat side of the part enables you with the smart mate with the pattern round holes. Smart mate cannot help you with the rectangular hex holes that were them in the best show of the sketch of the holes and place them in part with respect with the sketch at knees. 1514, place part. Create a feature-driven pattern with the insert component pattern. Feature-driven to try to use each of the pattern with the pattern part. For the new pattern, make a copy of the pattern part. Place it into one of the holes. Place the selected position option in the pick of the feature pattern instead of the original feature. After you have created a feature, few feature-driven patterns have the best understanding of how it's done. Right-click at the top level of the assembly feature manager. Select the collapsed items near the bottom of the menu. At this point, with example, simply with the placing a part with the pattern yet the existing feature pattern assembly will look at the figure 15. You will when you're done. Create a local pattern. Insert component pattern, linear pattern. Select one of the 3D sketches drawn in step 1 in pattern direction. Highlight the components and pattern selection box. Select the first part with the feature menu. Shift select with the last pattern. Feature of the patterns. Everything in the assembly. Make spacing 4 inches with 3 instances. Create second direction with even another sketching with 6 inches spacing 4 inches. Notice that how the preview shown in 12 inches of the patterns assembly. Select the option pattern sheet only. See how the preview changes 7 instances. Figure 15, 16 show the difference. Click on OK to accept the feature. Alright, the bottom line, performance and practice of the bottom issue that requires the compromise of the parent cause cover the performance reduction, both of the nature of reference however that can also improve the performance based on because of the need for the extra maybe the redo with the easier, simplify with the assembly, suppress with the pattern feature is driven the patterns, with the driven by the feature patterns of the transgress brass practice suggestions, but they also add parametric link, update the component pattern automatically. In addition, offers more options that are driven with the pattern option to be able to feature in this part. Master it, create a new part, multiple feature for the one of them being a whole of 2/10 of an inch diameter, making a pattern with the whole feature with this new part. When the assembly with the part with called the pattern part, solid part, pattern part, solid part is part pattern driven pattern using pattern holes for the new part you just created. Master create a new assembly with a template with the axis X, Y, and Z rate direction. You have the one called the axis assembly dot in the MBD template folder. Insert the assembly such as one of the sample bicycle wheel assemblies pattern in 3 direction. Master it, create a new assembly, open a new sketch assembly, create a closed loop sketch bigger than 6 inches on a side where all the elements for the tangent, no small fillets and tangents arcs between lines, create a curve driven pattern with a pattern part with a solid part, repattern in 2 directions based on the elements in the sketch, copy the sketch perpendicular plane with the assembly, create a chain pattern using same part, the distance, pitch method, and chain pattern property manager. Alright, Chapter 16, working with assembly sketches and layouts.